Alrighty, now we're going to actually get to graphing some functions that have been transformed. Let's take a look at example 1. We have f of x equals 3 minus 1/2 the quantity 1 minus 2x the quantity cubed. So the real question is, well, first of all, you should be able to identify which type of function this is. Because it's to the power of 3, it's going to be a cubic function. Okay, step 1 is to convert to standard form. So after you've identified which type of function it is, you need to arrange these numbers correctly. The number in front of the function needs to come first. So this negative 1/2, yes, do include the minus, needs to come first in the function. Next up, the number in front of the x needs to come first before this constant number. So you want to switch these two. So switch the 1 minus 2x to become negative 2x plus 1. And then finally make sure that the constant number away from the function goes to the end. So why do I say all that? Because here we can see this is our a value that's going to be multiplying into the function that we've studied previously. This is our b value in front of the x. This is our c value being added or subtracted from the x. This is our d value. And again, we know it's a cubic function because it's being cubed, so that's going to be our parent function. Step 2 is to determine a, b, c, and d, which I just went over. Here's the general form of our f of x function. And so a is negative 1/2, b is negative 2, c is 1, and d is 3. Now remember, you always subtract c, so we're going to be taking our x values and subtracting 1. If it was negative 1, we'd still be technically subtracting negative 1, but it would be the reverse, so we'd add 1 to the x values. We'll get to that in a little bit. Step 3 is to chart your parent function. Now again, I said that it is a cubic function, so you're going to chart what? You're going to chart p of x equals x cubed. Use the same x values that you normally use, negative 2, negative 1, 0, 1, 2. Just cube those values to get your y values. Alright, so there we have it. Now, there's only so many parent functions you can have, and again, you're going to be able to identify it just by seeing the special operation that's going on, whether it's a trig function or a square root of or whatever. Alright, next up, we're going to determine our x values. Now, I love this lesson because, we've already done the hard part. This is the easy part. We've already proven that you're going to subtract c from your x values and divide by b. So, take your parent x values, subtract c from them, and we just determined c was 1, so we're going to subtract 1 from each of these, and then just divide by your b value, which again we determined to be negative 2. It's the number in front of the x. And again, just do the opposite of what's in here, so since it's plus 1, you're going to subtract 1. If it was minus 1, you would add 1 to your x values. It's that simple, and that's because you're subtracting a negative, so it'd be positive. In this case, though, c is positive 1, so we're going to be subtracting it and dividing by b. I'd like to show two steps here in my calculation column. So in other words, I want to do negative 2 minus 1 is negative 3 divided by negative 2, just so I know I get this number right. So negative 3 divided by negative 2 is 1.5, and that gives me this gives me my final x value. It gives me my transformed x value, and I'm going to do that for each and every column to get all 5 of my new transformed x values. Good stuff. Next up, we're going to be determining our y values. Now again, I've already shown the proof for this. You're going to take the y values in your parent function chart. Okay, so these numbers right here. You're going to multiply them by a value, which we determined right here, the number in front of the function, and then we're going to add d. So in this case, it's going to be negative 1/2 times p plus d. So just take these numbers, multiply them by a, and then add d to them. And again, I like to show two steps here. Negative 1/2 times negative 8 is 4, plus 3 is 7, and do that for each and every row. And I'm going to get a new set of y values that are going to be my f of x values. So all you have to do is do x1 minus c over b to get your new x values from your parent values, and then do a times p of x plus d to get your new f values that come from your parent values. Then just take your new x values from this column and your new y values and create yourself your final chart. Once you've got this chart, you're just going to plot them on a graph. So for example, let's plot 1.5, 7. It's going to be right here, right? Then we're going to plot 1, 3.5, And we're going to go down the whole chart and plot these points and then connect them with the curve. We know x cubed is an S-curve, so when we connect this and draw arrows, it's just going to be a slender S-curve. Now, why does it look this way? Alright, so I'm going to take my original graph and transform it in order. So first of all, I'm going to make C, I'm going to move this up a little bit. I'm going to make C equal to 1, and we're going to see it's going to shift 1 to the left. Alright, then we're going to make B equal to -2. Let's go this way. Then we're going to make A equal to -1/2. So it actually has a horizontal flip and a vertical flip, as well as a vertical shrink. And then finally we're going to make D equal to 3. And we make D equal 3, it's going to shift 3 units up. So that's a confirmation of the graph that we just graphed using our chart and simple process. If you have any other questions about this, let me know.